All right, so what we're going to do now is we're going to do some examples where we're going to try and identify the equation of a logarithmic graph based on its base and based on its reflection, okay? All right, so let's try this one first. All right, the first thing that we can see is, well, the first thing we want to do is we want to draw in the asymptote and we want to plot the point. Now remember, with a logarithmic function, instead of it being 0, 1, it's 1, 0, okay? All right, so we're going to go ahead and draw in the vertical asymptote. How do we know where to draw in the vertical asymptote? Well, it's where the graph goes vertical. That's right here, okay? Now, I want you to notice that it's going vertical down. It's going vertical in a downward direction, which is the norm. That is normal. That is the normal shape, is for it to go vertical down. So we know that this graph is not upside down at all, okay? Well, it could be the normal shape, except that the normal shape goes to the right. It flattens out to the right, not to the left. Normally, it goes through the point 1, 0. This one is not going through the point 1, 0. It's going through the point negative 1, 0. Therefore, this graph must have reflected over the vertical asymptote, okay? And so therefore, since it's flattening out to the left, this is definitely backwards. So this graph is normal in its vertical sense, but in its horizontal sense, it's reflected backwards, okay? Because it's going off to the left, okay? So we know that when we write the equation here, it's going to be f of x is equal to, it's not going to be negative because it's not upside down, so it's just going to be log base something. We're going to put some number here of, and it's going to be negative x, because it is reflected backwards. Now we just need to identify the base of this logarithm, okay? All right, so we're going to go from this point here. We would go up or we would go down 1 unit, just 1 unit, okay? And we're going to go the direction where it's going to put us between the graph and the asymptote. Well, going down does not put us between the graph and the asymptote. Going up does, okay? So we're going to go up 1 unit, go over to the asymptote right here. We're going to count the distance from here over to the curve, which is right here, okay? And the distance there is 1, 2, 3, 4, 5. So this logarithm has a base of 5, and therefore this is log base 5 of negative x, okay? So f of x is equal to log base 5 of negative x. Now what I want to do is I want to show you how you would enter this into a computer. Okay, so let's say you don't have access to subscript. See this 5? See, it's tiny and it's down by the bottom of the G. In some programs you have a subscript, but in many programs you do not. So let me show you how you would enter log base 5. Okay, to do a subscript, so you type LOG. To do a subscript, you do an underscore. Okay, so LOG underscore, then 5. This means log base 5, okay? Then you're going to put parentheses and put negative x, and you're done, okay? So this is log base 5 of parenthesis negative x, close parenthesis, and you're good to go, okay? Let's try another example. All right, here's another one. If you want to pause the video and see if you can figure this one out on your own, go ahead and try that. All right, so the first thing I'm going to do is I'm going to draw in the vertical asymptote. So I can see that it goes vertical on the y-axis right here, right? So I'm going to draw in the vertical asymptote, okay? And now I'm going to draw in the point, right? Okay, so I'm going to go 1 unit over from the vertical asymptote, and we see that it's going through the point 1, 0. There we go. Now, because it's going through 1, 0 and not negative 1, 0, we know that it's not backwards, right? It's pointing off to the right. It's getting flat to the right. Therefore, this is the that means that it's not backwards. Also, it's going vertically. When it goes vertical, it's going down. Therefore, this is the normal shape, because the normal shape is vertical down and flat to the right, correct? Or flatter to the right. So this is a normal shape. This one is not going to have any negatives at all. It's going to be f of x is equal to log base something of just x, right? No negatives at all. Now we need to know the base. So from this point right here, we're going to go either 1 unit up or 1 unit down. We're going to go 1 unit up because we want to go to where it's between the curve and the asymptote. And then we want to go over to the asymptote, left. And then from here, measure the distance all the way to the curve, which is right there. There it is. And so now that distance is from here 1, 2, 3, 4, 5, 6, 7. So this logarithm has a base of 7. So this is f of x is equal to log base 7 of x. Okay? If you wanted to type it into a computer, it would be log_7 for log base 7 parenthesis x, close parenthesis, and that would be your answer. Okay? Let's try a couple more. All right, so first thing we want to do is draw in the vertical asymptote. We can see that it goes vertical here again at the y-axis. So we're going to draw in the vertical asymptote, right? Okay, now, interesting, look, instead of going vertical in the downward direction, this one is going vertical in the upward direction. That means that this graph must be upside down. Therefore, this one is definitely going to have a negative on the front of the function. Okay, so this one is upside down. Something else that's interesting is that the normal shape goes vertical down and flat to the right. But this one goes vertical up, meaning it's upside down, and it's going flat to the left. Therefore, this graph must also be backwards. This graph is upside down and it's backwards. Therefore, it's going to be f of x is equal to negative log base something of negative x. Now we just got to figure out what the base is, log base something. All right, the base, to find the base, so we're going to go 1 unit over from the asymptote to the point -1 and 0. Normally it's 1, 0, but this is -1, 0 because it's backwards, right? From this point, we're going to go 1 unit up or down. Normally we go up, but because this is upside down, we're going to go 1 unit down. And then we're going to go over to the asymptote here, and we're going to count the distance from the asymptote over to the curve, which is right here. And you can see that it's not quite at 3. At 3, it's clearly past 1, okay? Or -1, sorry. And so, so it's not at 3 and it's not at 2. It's somewhere between 2 and 3, and it's closer to 3. Therefore, this must be e. Therefore, this is going to be negative log base e of negative x. But remember that we don't write log base e. When it's log base e, we write ln. Okay, so it's negative natural log, or negative ln of negative x. And the way that you would enter this into into a computer, if you were typing in an answer, you would put the negative first, then L, then N, then a parenthesis, then negative x, then close the parenthesis. So negative natural log of negative x. Okay, let's do just one more example. All right, for this last example, why don't you go ahead and pause the video and see if you can figure this out on your own. All right, so the first thing we're going to do is we're going to put in the vertical asymptote, so we can see that it's going vertical right here at the y-axis again, because we haven't shifted it yet. We haven't done any translations yet. So there's our vertical asymptote. Now look, this one is going vertical up in an upward direction. We know that normally it goes vertical in a downward direction. So this is definitely upside down, okay? And we also know that normally, under normal circumstances, it goes flat to the right. Well, this one is going flat to the right, okay? Now, it may look a little different. It's going flat to the right below the x-axis. Well, that's because it's upside down, okay? So this is not backwards, okay? If it was backwards, it would be over on the left side of the asymptote, okay? So we know that this is going to be f of x is equal to negative log, right, of some base of x. Not negative x, just x, because it's not backwards, okay? Now we just got to find out what the base is. All right, well, we'll plot the point 1 unit over from the, here's the asymptote, go 1 unit over from the asymptote to right here, and that's the point 1, 0, okay? Then we're going to go either up or down, and because it's upside down, normally we go up 1 unit, but because it's upside down, we're going to go down 1 unit. We're now between the asymptote and the curve. We're going to go over to the asymptote right here, and from here, we're going to measure the distance from there over to the curve, which looks like a distance of 3. Therefore, this logarithm has a base of 3. Therefore, we have negative log base 3 of x. The way you would enter this into a computer in a box would be negative log underscore 3 for base 3 of parenthesis x close parenthesis. So negative log base 3 of x, okay? All right, well, that's it for this. If you get good at this, if you're really good at this, you should have no problem. In the next lesson, we're going to move on to understanding the graphs of logarithmic functions with vertical translations and horizontal translation.